Hi, this is Eric with 30 by 40 Design Workshop. Today we're going to be talking a little bit about how to design your own home music studio. While a home music room may not have the demands of a professional recording studio, many spaces can benefit from the sound isolation and acoustic treatment applied to rooms designed for playing music. I've designed spaces for music at all scales, from auditorium halls to private listening rooms, and have learned a few basic sound concepts that can dramatically improve the aural environment of any space. We'll start with planning. Understanding the use of the space is the first priority. A practice space for your garage band and a space used for vocal recording or listening to chamber music will have some obvious differences. The location of the studio space will greatly affect the degree to which you'll need to isolate it from the rest of your home. Imagine how the sound isolation requirements for a practice room located next to the nursery versus one in the garage might differ. No amount of acoustical caulk is going to make the former practical. Sensibly locating the music room is step one. Isolating listening and recording spaces from outside noises coming from the street, your neighbors, and even mechanical equipment is a high priority. So is the actual size of the recording equipment. So interior, lower level, windowless locations are good starting points. But true recording studios are so nuanced that an experienced professional should be involved from the outset to be sure your goals are being met. More informal performance and practice spaces are usually more concerned with containing the sound transmitted from them to adjacent spaces, as well as with sound fidelity and instrument housing, and some instruments can be quite large. For these spaces, isolation construction strategies and controlling how the sound behaves in the space are more important. The next part of the planning is defining the actual proportions of the space, the shape of the room. There's much debate in the acoustical design community regarding the ideal proportions, and the math gets complicated pretty quickly. For the casual audiophile, though, it's generally accepted that the Greek golden mean proportions of 1 to 1.6 to 2.6, height by width by length, will yield an acoustically pleasant room. As an example, if we begin with a typical 8-foot ceiling height as a starting point, we should aim for a room that's roughly 13 feet by 21 feet. The space shown here makes use of a clever device that can alter the shape of the room and its acoustics. The pivoting panels seen at the rear wall of the stage area can be used to fine-tune the geometry and control the way sound is reflected around the room. A few other guidelines to follow. 1. Larger volumes are always better than smaller ones. 2. Avoid completely regularized forms. Perfect cubes and long, narrow spaces with parallel walls are poor acoustical performers. 3. Irregular shapes and surfaces, walls, floors, ceilings, bookcases, as well as convex forms allow sound to be diffused in a space, which is desirable. 4. Avoid concave surfaces, which tend to focus sound. 5. Avoid room dimensions that are direct multiples of one another, 1 to 2 to 3. For example, a 16-foot by 24-foot room with 8-foot ceilings, because these will amplify resonating frequencies, making for an acoustically muddy and noisy space. And lastly, avoid parallel walls and flat ceilings. These are generally considered a bad thing in acoustical design because parallel walls turn a space into a tennis match of sorts, bouncing sound waves back and forth between the wall surfaces and causing echo and flutter. This is one reason performance halls are shaped the way they are, with splayed walls, floors, and ceilings. If you're repurposing an existing space with less than ideal room proportions, don't worry. Absorption strategies can help to overcome this shortcoming. But more on this later. When sound waves strike a surface, there are 3 things that happen. Some of the sound is reflected back into the room, some of it is absorbed by the material, and some of it is transmitted through the material. These are the 3 main things we control when designing a space for music. Reflection. Hard surfaces reflect and disperse the sound energy in a space. Soft surfaces absorb it. Much of contemporary architecture is defined by hard lines and surfaces, like concrete, hardwood, and drywall. These are all highly reflective surfaces. The bouncing of sound is known as reverberation. For a live recording environment, a certain amount of it can be desirable, but reflection generally needs to be controlled. This is especially true for smaller music rooms, so it doesn't render the sonic nuances of the music unperceivable. We control reflection primarily in 2 ways, through diffusion and absorption. Ideally, a music room has surfaces that diffuse or break up the sound waves and scatter them about. Rough surfaces, like the exposed framing seen here, brickwork, rough stone, wood slats, and fixed or pivoting panels all aid diffusion. But too much reflection will make music sound muddy in a room. To counteract this, most rooms need some means of absorbing or deadening sound waves. Absorption. To reduce the sound energy in a space, we use absorption. Rugs, drapery, couches, and wall hangings will all help to absorb sound, especially at higher frequencies, which are usually perceived as unpleasant. Absorption in a room controls reverberation and reduces ambient noise in spaces without a lot of furniture or drapes and many hard surfaces. Special acoustic absorbers made out of foam or acoustical plaster can be used to deaden a room. You've probably seen egg crate acoustic foam absorbers before. Obviously, absorbers can look strange in the home environment, but there are creative ways to cover them, as with this colored fabric applied to a special acoustically absorptive surface. There are also acoustically porous plaster finishes available, which look no different than standard drywall, but absorb rather than reflect sound energy. Absorption shouldn't be confused with our next control point, isolation. Adding absorbers in your garage won't keep the sound from being transmitted to your neighbors. It will only improve the way the space inside sounds. Transmission and isolation. To keep the peace with your neighbors, you'll need to focus on isolation. Because sound is transmitted by vibration, it makes sense that to minimize sound transfer between spaces, we should minimize their points of contact. In standard wall construction, walls that separate spaces typically share framing members, the studs. To truly isolate a space acoustically, you want to keep the perimeter framing of each space independent from the adjacent spaces as well as from the surrounding structure. This includes the floor and the ceiling. Many acoustical designers refer to sound isolation in construction as decoupling. The goal of it is to keep the sound waves from touching the structure of a home and allowing it to vibrate. There are various means of decoupling. You can use floating walls that are framed independently and isolated from the surrounding structure with special padded isolation clips and hangers. You can isolate the mounting of materials using resilient channels and wall clips to hang drywall. You can isolate the vibrations induced by building systems like plumbing pipes, electrical appliances, and mechanical equipment. You can add an airspace between walls to create a sound isolating medium. Seal all the joints, including electrical outlets, studs, drywall, doors, windows, and trim. You can use specialty acoustical products like membranes, mass-loaded vinyl, underlayments, and acoustical insulation. You can use specially insulated duct treatments and grills to minimize air noise too. Think of your room as being like a fish tank. Any openings, even small ones, that aren't sealed will leak. It's these leaks that can undermine all of your hard and expensive soundproofing efforts. This means larger openings like doors and windows need special care. For the best sound isolation, an airlock consisting of two back-to-back doors is ideal. The door bottoms should have self-actuating bottom gaskets that seal when closed. For windows, you'll want insulated units with at least one of the panes made of laminated glass. Resonance in construction. Most residential walls are constructed using 2x4 studs with half-inch drywall as a finished surface. Think of a wall as a giant speaker. It will have a frequency at which it resonates. Acousticians call this room mode. For a recording environment, resonating walls can muddy the sound of the room. This is especially true of small rooms because there's less room for the sound to dissipate. By simply varying the thickness of standard materials on the walls, we can decrease the chance that resonating materials will be a problem. For example, alternating half-inch drywall on one side and 5/8 inch on the other will ensure that the resonant frequencies aren't the same. Retrofitting. So now you know a lot more about how sound moves and how you can control and contain it, which is great information if you're designing from the ground up, but many of us don't have that luxury. Converting an existing space can essentially be done in two ways. The first is by adding acoustical treatments to an existing room. You can modify the absorption and diffusion fairly easily in this way, even altering the room shape is possible with freestanding panels or objects. This option is most appropriate for renters because it's less permanent. However, it's also less successful because acoustically isolating a space is a difficult and more intrusive process. The second way is by designing your studio to be a room within a room. If you have the room and a plan to stay put long term, this is the better solution. The more you're able to isolate your studio from the surrounding structure, the better. If you're able to construct floating walls, use a gasketed door, double the layers of sheetrock, and add some absorptive materials, you're well on your way to creating a dramatically improved acoustical environment. For a garage space, consider adjustable features like large swinging or sliding doors, which can help to both contain transmitted sound and act as diffusers. Add coverings or drapes to any existing windows to help minimize unwanted reflections and increase absorption. Open framing in a garage is actually acoustically quite nice, but an uninsulated garage can make for some tense neighborly relations. By adopting the room within a room approach, you'll greatly reduce the amount of sound transmitted to the outdoors in a garage space. This interior room lining can be constructed using relatively inexpensive off-the-shelf materials if the concepts discussed are followed. Isolate first, then balance absorption and reflection. Good luck with your